Welcome to the webinar for mold tools in 3D Interconnect. If that's where you want to be, then then you're in the right place. So I'm Brian Sprange. I'm a applications expert here at Javelin, and I'm just going to go over some of the things we can do with 3D Interconnect and molds tools and how they can kind of work together, and also just how they function on their own as well. Let's just wait for a couple more people. Well, I'm sure we'll have a couple stragglers come in a bit late, but that's all right. And so I guess to start off, Javelin, as you may know, if you're a customer, we've been in business for about 20 years. So we're celebrating our 20th year this year, and we've got a bunch of, or we had a bunch of barbecues around Canada and stuff like that. So hopefully you guys are able to make it out. And so this, as I said, this is a webinar on how to use mold tools, kind of a quick demonstration, and also 3D Interconnect, how that can work with mold tools and also on its own, some of its features. So to go through the kind of process we'll go through, first I'll go and do an overview of mold tools, then we'll talk a little bit about 3D Interconnect, and then kind of how we can make tooling and also part holding devices using 3D Interconnect, so with supplier parts, or maybe if you have two CAD modeling softwares installed and you're wanting to use one for a specific reason, how you can keep all your files up to date. And then finally we'll end off with a bit of a question period if you have any questions regarding the info that I've passed along. So to start off with mold tools, we'll go over to SOLIDWORKS and just do a quick demo of what we can, what some of the features of mold tools are. So I'll open up this switch cover part here. And so to start off, we see it's got a couple holes. It's probably a plastic part, and we'd want to make a mold for this. So what we can do is actually just go into the Mold Tools tab, and this is the standard SOLIDWORKS Mold Tools tab, except for one item, which is the intersect command over here, and also the thickness analysis, so two items, I guess. So what we'll do is actually run through this command line, basically, and just kind of see how each of the tools works. First thing we can do is run a draft analysis on this. We'll use this plane here, and we can see it's pretty good for draft. We're missing it on the cylinders, but that's all right for the case of this part. We'll just ignore that fact. So we'll close that off. If we had wanted to keep looking at or keep that view on, you can actually check it, and then if you're wanting to make some changes, it'll live update as well. So now that we've checked that this part has draft and we know which way we're going to do things, what we'll start off with is just on the left here, we'll start with parting line. So the first thing we're going to do is choose the plane that we want to use. Again, we'll run that draft analysis, and that's going to collect all the faces for the core and the cavity, and also it'll auto-select the parting line if there's a clear distinction of where it'll go. So we'll check that off, and we have our parting line already pre-selected. It's ready to go. Now the next thing we want to do, and if we just follow along this order, we have shut-off surfaces. So we'll click on the shut-off surfaces, and sometimes it won't run properly. So if that happens, what I find works really well is we just go back into the parting line, just make sure that everything is correct. Sometimes just rerunning that function, and then it still isn't working, of course. So I'm actually just going to delete this and run it again. And I've got a window that's popped up. All right, it's hiding behind other things. Sorry about that. So run the parting line tool. We'll grab that plane, run the draft analysis. Once again, it auto-selects everything that we need. We'll check that off, and now the shut-off surfaces work properly. Sometimes there's a bit of an issue. I probably should have restarted SOLIDWORKS. That's just been sometimes. So you can see it auto-selects those loops to close off those surfaces. So we'll check that off. And then cruising right along, we have our parting surface command. So what that's going to do is actually make a parting surface. We have the option of manual mode. What that'll do is if we have some complex areas like right in here, that'll just clean it up for us by letting us kind of decide where each of these is going to go. You can see each node has a point on this representative square out here, so we can actually move those around and change the shape of that parting surface. We'll make this parting surface a little bit bigger as well, just to make it a bit clearer as to what we're doing. And you can see in here we don't really have something we would want to necessarily see. So what we'll actually do is just right-click here, and there's an option to start fill surface region. So then if we go over to this side and click on this point, again, right-click and end fill surface region, what that's going to do is it's going to, once again, not work properly. Apparently I'm fighting with SOLIDWORKS today. So I'll just try that again. Sometimes if you don't quite get the node, it doesn't work quite as you would expect. So we'll do the start fill surface and go over here, grab that node and fill surface. And it's just being a pain today. All right, let's see. Try it one more time before we reset a little bit. Sorry about the issues today. There we go. That's what we're looking to see. So we can see it fills that in. Normally that works very well. Apparently this today SOLIDWORKS is grumpy. So we'll check that off. And we can see we have our parting surface now. So finally we'll click on this last one here for the order. We'll go tooling split. We're going to choose this plane. Just do a quick center rectangle on here. Add a couple of dimensions. Just to have a fully defined sketch. And with that, we can now get our tooling splits. See, SOLIDWORKS has automatically grouped all of our core surfaces, all of our cavity surfaces, and all of our parting surfaces. And I can show you why that is. We're going to need an interlock so that we can get that out because we didn't have the parting surface go all the way through the tooling split. So we'll check that off. And now if we look a little bit further up here, when we decided to make this into a mold and we ran that parting line analysis, we ended up with the surface bodies folder because what it's done is actually gathered, it's taken the solid body and actually split that up into the surfaces and also the shut-off surfaces. So it just cleans everything up, keeps everything organized, and if we were wanting to make some changes, we can actually go into these folders. If we wanted to use a different parting surface, we could actually just drag and drop a different surface into that parting surface bodies. But we're going to use the ones that SOLIDWORKS is defined by default here in this case. So now we have this part. How do we see it? If we just go into this move copy bodies, we could do an explode, but this way we're able to actually just move that out of the way and kind of see what SOLIDWORKS has made. So we can see we have our part here. We have our core and our cavity. You can see all that data is brought across. So that's great if we're using SOLIDWORKS part, but maybe if we're wanting to use a supplier part or something that from a different software, how can we do that? So we'll jump back to our PowerPoint here. So some of the advantages of the mold tools is it is really easy to use. Typically it doesn't have quite as many errors as I ran into there. That's probably just I've been running through this a couple times, so maybe it got a bit bogged down and we need to do a restart, but it's an efficient workflow. You just go from left to right and it auto recognizes. So you can see it automatically grabbed my parting line and it also automatically grabbed those shut-off surfaces for me. So it saves time when I'm working because I don't need to go through and select those loops. Maybe if your part has hundreds of holes in it, it's much easier to just click one button and then check it off as opposed to going through and selecting all of your loops. So the next thing I want to show you guys is the 3D Interconnect functionality of SOLIDWORKS. But before we do that, I just want to kind of get a litmus test of what everyone knows about the 3D Interconnect. So I'm just going to run a quick poll. And so I'll launch that now. And basically just it's asking if you've used 3D Interconnect, if you've heard of it, and if you knew that 3D Interconnect can automatically keep links with your parts. Not only does it make it make loading the parts easier because it just opens them as if they're native data, but it also allows you to update when those parts get updated. So if you just want to answer that poll quickly, we'll run that for a couple or about probably 10 more seconds. And then we can go from there and kind of get an idea of what everyone's looking at. So it looks like most people have not used 3D Interconnect or they didn't know that it can update. So that's good. This should be a nice informative session here. So what I'll do first is I'll close that poll. All right, so going back to the PowerPoint here, we're going to look at some of the 3D Interconnect functionality. So I'll close this part down. And what I'm going to do is actually open up a Inventor part or an Inventor Assembly. So you can see here the extension is IAM. This is a native Inventor assembly comprised of 3 different parts with multiple instances. So it helps if you open it from SOLIDWORKS. If you open it from Windows and you don't have Inventor, it's not going to know what's going on. So we'll open it up and you can see it's reading in the model, it's loading in the models, and it's just going to open it up in SOLIDWORKS as if it was a native SOLIDWORKS file. First I had to specify, it was over on my other screen, that I'll use an assembly template here. So what we get is an assembly. These aren't imported parts, these are actually, they have a special icon over here. So you can see it's got a part icon with a little green arrow basically saying that it's linked back to the original part file. If I take this cover and let's make it transparent so we can see what's going on in here, we've got 8 batteries. They look like they're maybe AA's or something like that. And this is the battery pack for, if you've seen a demo this year, maybe the Myomo, MyPro Arm Assist, I guess. So this is the portable power source for it. And maybe we're building something around it, but this is an Inventor Assembly. So what happens if partway through testing we discover that actually we need a bigger battery pack, so we're going to get a different version. What we can do, if I had Inventor, you could just save over those files, but I don't have Inventor, so I'm just going to basically just replace those files in here. So I'll replace the files. Keep in mind I currently have those files open in SOLIDWORKS. That's not an issue, so I've replaced those files, and what we can do is just run a quick update at the top here, and then you're going to see some things change here. You can see that there's a new little icon right here. There's a little refresh icon. So if I right click on here, I have now the option to update the model. If I run update model, we're going to see it's going to reopen these. And what's the advantage of this? Basically, if your supplier is changed their parts, maybe you're downloading parts from McMaster Car or Car Lane or something like that, if you're wanting to change something out, instead of having to redesign anything you have designed around this, you can keep your design intent, you can keep your model. You might have a couple of errors just if the model changes drastically, but for the most part, everything is going to just transfer really nicely. And the reason for that is the 3D Interconnect, it's not translating or importing anything, it's just opening them as if they're native files. If we say have this face up here, that face within the CAD software has a face ID, and SOLIDWORKS is keeping that face ID. So if you have things linked to that face, maybe assembly mates, or if you're modifying these data sets after the fact, you'll find that they will stay linked. So that's kind of just a really quick overview of 3D Interconnect and what it can do. This is a SOLIDWORKS 2017 functionality. There are already some pretty exciting changes possibly happening in 2018 to it, and by changes I mean updates. So without spilling the beans, basically any of the functionality we currently have is going to be even better for future versions of SOLIDWORKS. So it's really exciting, kind of a little tidbit there. So I'm going to close this off. You can see when it updated, it didn't really make much of a difference because we're just looking at the parts, but where could this be useful? If we close this off and we're just going to jump back to the PowerPoint here, we can see the part compatibility. We can keep everything compatible. It can just open it as if it's a native document. And as I mentioned, it has those face and edge IDs. It knows what those faces are. So if you have a face that's just moving, you're not going to lose you're not going to have dangling dimensions. You're not going to lose your design intent of using that face as a reference. It will keep that reference. And it also just makes it really easy if you have supplier parts to do updates or anything like that. So if we take that one step further, and maybe we want to use a supplier part, maybe we're making tooling around it, or we've been asked to make tooling, or if we want to make a mold, or even just reference it. So how can we do that? So what I'm going to do is I'm actually going to do kind of a bit of a mold tools and also a 3D Interconnect demo here. What I'm going to do is actually open up a gear. So this is part of the Myomo Myo Pro assembly. This is the main drive gear that would lift your arm if you needed that. So we're just going to hide a couple planes there just so they're not in the way. You can see we have a pretty simple gear here. This is a Pro E file. So what I'm going to do is instead of going through the mold tools, regular flow, what I'm actually going to do is just run an intersect. And by so to do that, I'm going to first make a sketch on here, and I'm just going to make, let's say, just a generic size mold base or a random size mold base, 150 millimeters by 150 millimeters, let's say. So we'll check that off. And now I'm going to right click on here using the in context toolbars, just quickly make that into an extrusion. And the only thing I need to remember is that we can't have merge result on, otherwise it's just going to consume that gear. So I've basically made a simple tooling block around that. But if we were to do a section view of this, nothing's been cut out. It's still that gear is still inside here. It's not actually cut out. That's just some graphics things going on there. Basically, if I hide that gear, I have two bodies here, right? So I have a simple rectangle or a simple cube and that gear. So if I run the intersect command, what I can do then, and this is on your main toolbar, is I'll choose the plane, and then I'm going to choose the block, and I'm also going to go in and choose that pulley or the gear. What that's going to do is it's going to basically find everywhere that they intersect all of those objects and calculate regions. So I can use this to make a cavity mold really easily, really quickly. It's going to be a little bit more crude because you're using just a simple, you can use it with a plane or a surface or something like that. For this one, I'm just using a plane. And what I'll do is I'll just hide that front face there just so we can see what's going on. And when I check that off, we can see that now I've actually made that mold. So, and that's pretty nice. It's really quick to get to. But where's the real advantage with this is when we start looking at actually using this. So we've used this part to make the mold, but maybe we're wanting to put some water lines and other stuff in this mold. I've got a bit of a pre-made model here. So, and also this is going to show a couple other things. So what I'm going to do is just open up this waterline model. So we look at this model, I've got some water lines put in. These are library features. So these are maybe their company standards, and the way they're put in, we can put them in just by sketching out some lines for where we want them to go and then dropping them in. You can see I have one more left here, so I'm actually just going to go in and drop that in. We can go into the library. These are really easy to make. We go over how to make these in our Essentials class. We're just going to drop them onto there, or we go over how to make library features in the Essentials class. These specific mold tools, this is in the mold tools class. So I'm just going to drop this library feature in here. You can see with a simple drag and drop onto a face and then selecting 2 points, I'm going to get that geometry that I was looking for. And this can be really useful if maybe we're using this as a mold, and then you basically got through your mold design, and then either you decided you wanted to use a different part, or maybe you're building this mold for someone and they've changed their mind. Well, that can be a pain normally, but with SOLIDWORKS it's not that bad. So what I'm going to do is, you can see this is, I have this SOLIDWORKS part file here, and I also have this part that I just made here. They're both based on the same file. I'm going to go in and update that file. So with Pro-E, you get a .2 file. I'll go in, copy paste that into that folder there as if I had made a new version. And when I do a rebuild on here, we're going to see we have that update option. So that update option, that's great. I have two models open right now, but I only want to update this one maybe. If we only update this one, that's not a problem at all. We can basically pick and choose when we're going to update, or if we update it all, we can keep working once a part has been updated. Because it's Pro-E, it has that versioning capability. So we can see here that part has been revised. We have some different size, different geometry, but that intersect that we ran is still working because it still knows where everything is. So we'll just run a quick move bodies on here. Oh. But what did we see? So I'll just drag this back over here, and what we saw is that we can have we can easily make molds if we need to using the intersect tool. And we can also, everything stays linked. We can, because of that, when it's linked, we can do future designs based off of an imported part, maybe something from Carlane or McMaster-Carr or from a supplier, and not lose that design intent. That's the biggest thing. When you're designing something, if you're designing with your design intent, when something updates, if it keeps that face, you're going to have, if you have offsets based on that, or if you're basing your size based off of the size of a component, you can have things that'll stay linked and keep working. And also we have the option to update. So unfortunately I wasn't able to show it, but we updated the one file. I had the other one still open and it hadn't updated yet. Basically it gives you the option of when you want to update that part. It does the initial import when you first open the file, or the initial opening, and then it makes it into a SOLIDWORKS document, so you can keep it at that state as long as you want if you got new models from the customer, or if you wanted to update your models, then you can basically pick and choose when that'll happen. So to wrap up, the mold tools, it's really easy to use. It's really laid out in an easy method. It's very step-by-step. With 3D Interconnect, you can keep your supplier documents that are non-SOLIDWORKS documents linked up with your suppliers. So you can make sure if they're sending you new documents or new files, you're not going to have to redo your design work. You can basically keep going from where you're at, update their base file, and occasionally there'll be little areas that you have to fix, but they're always really easy. And for the most part, it's going to just keep everything linked up as if it had never been changed in the first place, as if that was the first model you did. You don't have to redo your work. And then finally, you can really easily, there's a couple tricks with using that intersect command to make molds really quickly. And also basically using 3D Interconnect with your molds, you're going to keep your supplier data up to date always and make sure that you're making your molds to the right part. And even if there's a design change, it's not that painful to go up and update them in the future. So I guess that's pretty much what I have to show you guys. If there is any questions, please feel free to type them out, or I'm not sure if you guys are able to mute yourselves. Looks like there's a couple questions here. See if I can answer some of them right now. Is it mandatory to use 3D Interconnect with mold tools, and can someone survive without it? It is absolutely not mandatory to use 3D Interconnect. You can run through a regular import process, or you can just open the part, and using 3D Interconnect, it makes it faster to open parts, and if you don't need to use the functionality of updates, you'll just you wouldn't even notice that you're using them if you didn't need to use them, basically, I guess, if that makes any sense. So I guess to elaborate, if you're using 3D Interconnect, it just makes it easier to open, and if the supplier part updates, you wouldn't even need to update if you don't want to. You're given the option. It doesn't do it automatically. I hope that answers your question. Looks like it did. All right, great. Are there any other questions related to that? I know I kind of ran through that quickly. Hopefully that made sense. Looks like there are no other questions. So as I said before, I'm Brian Sprange. If you have any questions regarding any of this information, please contact either your salesperson. They can get you in touch with me. Unfortunately, I didn't put a slide with my contact info in here. However, if you have your easiest contact number for Javelin, my extension is 307. You can also send me an email. I think my information might have been in the webinar information. If not, it's brian.sprange@javelintech.com. Yeah, hopefully this was helpful for people. If there's any questions, again, please write them out. I'll stay on the line for a little bit, or you can give me a call or send me an email. Got a question here. Can I open an Inventor file from the server or from a server instead of a local disk drive? Of course you can. You can open it from a floppy disk, from basically a thumb drive, any method you can use to open a file. So even if you had it in SOLIDWORKS PDM, you could open up that file, no problem. It basically, any method you could use in Windows Explorer or with SOLIDWORKS to open a file existing, you can open that with 3D Interconnect. So in that, it opens it as if it was the native data, and you can run further import options if you wanted to do some feature recognition on that. At that point, you have that option, or you can just use that part as it's been supplied to you. Does that answer your question there? Perfect. Yeah, 3D Interconnect, it works as if you were opening a SOLIDWORKS part without it being a SOLIDWORKS part, basically. So it lets you use that, use a competitor's geometry or use a supplier's geometry and import it into SOLIDWORKS and just continue on using it as if it was originally designed in SOLIDWORKS. So if there's any other questions, either raise your hand or type them out. If not, I guess we'll probably end it around there. Thank you for logging in, and please let me know if you have any questions relating to any features of SOLIDWORKS.